to Revit tutorial basic architectural modeling with simple structural components. We use the model developed in previous sessions. This model has been modified by taking away the bearing wall, footing and a number of concrete beams at roof level. Now let's have a look what we have in the model. Simple 3D model layout for double-story residential house. At level 0 we have a bedroom, living room, hallway, etc. At level 1 there are additional accommodation such as study room and home office. Note that we have slabs in the wet area such as toilet, utility and kitchen, where the level is different from other accommodation in level 0 and level 1. We can do this by offsetting the slab 30 mm from existing level. To create a floor slab, click Architecture tab. The wall is now grey out and you can now create a slab. In the Properties palette, type selector, select floor, ground, beam, floor, or any ground bearing floor you can find from the options. Height offset from level is -0.030 and click Apply. Go to Modify, Create Floor Boundary tab, select Rectangle 2. Always start from the center line of the external wall and stop at the center line of the opposite wall of the starting point. Make sure the edge of the slab at the door side align to the inner face of the toilet wall. This makes sense because when you walk in the toilet, the slab will drop from inside of the toilet. Now in the property palette, in height offset from level, set it to 0 and place the slab between toilet and utility. Notice that this is a warning line overlapping between the slab and it may not form close loop, meaning that the Revit recognize that two rectangles you have drilled are coincident. If you click Finish, Revit will stop you to complete the commands and force you to quit the slab you have placed. If you placed two rectangle objects side by side with a coincidence edge, you will need to draw the two objects separately in Revit. You can undo the last rectangle and click Finish to complete the rectangles for toilet, utility and kitchen and start to draw the slab in a new sessions. In this instance, I choose to continue and Revit will stop me from completing the task. I have to quit and redo everything again. In order to see the cross-section view of the slab, we need to insert a section view. From View tab, create panel, select section, and place the line vertically across the wet areas. Double-click section to open section. In the View control bar, click Detail Level 2, select Fine. It provides a new cross-section view where you can see the differences in the levels of the slab you have created. Now you can see the ground bearing slab in the wet area lower than the adjacent slab. We can reduce the slab thickness to match with the adjacent slab level. Left click to select the wet areas slab. Go to Properties palette, click Edit Type. This will create a Type Properties dialog. Notice that the default thickness is 480 mm. Click on Duplicate Floor Ground Bearing 450 mm. Rename the slab by the new thickness in Value column. Click on Edit in Edit Assembly dialog. go to line 9. We want to reduce the hardcore thickness by 30 mm. Change 150 mm to 120 mm. Click OK to complete the edit assembly. Now return to Type Properties dialog. The default thickness becomes 450 mm. Click OK to complete the duplication. Go back to the section view. The wet area slab level is now matching to the adjacent slab. We can use the same method to modify the slab thickness at level 1. In Architecture tab, go to Circulation panel, select Stair command. In Modify Create Stair tab, go to the Components panels, click on L-shaped winder. To place the L-shaped stair, you need to specify where you want to start the lower end of the run and left click to place it. Press spacebar key to rotate in your keyboard before clicking to place it. The wider stair automatically connects the base, which is the level 0, and top elevation, which is level 1. You can use the left, right, up and down keys in your keyboard to move the stair to the location you want to place. Notice that there isn't a landing when using L-shaped winder tools to add a stair. Now delete the stair. We use the Runs tool to create a stair. Click on Runs command. Notice that when you click to run the start point is the center line of the stair. As you move away from the start point, Revit will calculate the remaining rises automatically. Once completed, we can reposition the stair to make it close to the wall. Select the stair and relocate by using the left, right, up or down keys from the keyboard. Take a look at the stair. We can see at level 1 we need to modify the slab to make way for the stair. For a better section view of the building, we can create a 3D section box view. Go to Project Browser, 3D View. Right click to select Duplicate View. Duplicate with detailing. Create a copy of a 3D view. Now go to Property Palette under Extends category. Tick to check the section box. Note that there is a box outside the 3D model where you can click on any of the lines. It becomes a blue line, meaning that you can select any direction as indicated in the line to create different section view for the stair. Now from the section box view, we can see we need to have an opening at level 1 for the stair to come through. Modification for slab opening. To do this, in the 3D section box view, double click to select the slab. A pink color line appears to indicate that the slab is ready for any modification. At level 1, modify Edit Boundary tab, Draw panel, select Rectangle tool. Draw a rectangle to modify the floor boundary. Now go to 3D section box view. There is an opening for the stair comes through. Hide the external wall and window to get a better view for the stair. We now need to place a railing at the edge of the opening. To do this, at level 1, go to Architecture tab. From Circulation panel, select railing command. From the drop-down, select sketch path. From property palettes in the type selector, select railing with 1100 mm. Now we can draw a line on the edge for the railing. To add a ceiling, go to the project browser, click on Ceiling Plans, Level 0. Note that we don't need to draw the ceiling at the staircase area. Click Architecture tab in Build panel. Click on Ceiling command. In the Property Palette Type Selector drop-down, select Generic Type. In the Ceiling panel, click Sketch Ceiling command. This will create, modify, create ceiling boundary tab. In Draw panel, we can use either line or rectangles tool to draw a ceiling. Notice that in Property Palette under Constraints, the level is level 0. Height offset from is 2.7 meter and the room bounding is thick. After adding the ceiling for all the accommodation in level 0, click Tick to finish the command. Go to Ceiling Plant View, level 1, and click Architecture tab. In Build panel, click the Ceiling command. Select Sketch Ceiling command. This will create, modify, create ceiling boundary tab. In the Ceiling panel, select Automatic Ceiling tool. Place your cursor to the accommodation, left click, and this will automatically place a ceiling to the accommodation. Now go to the 3D section box view. To add a roof from the roof level, go to the roof floor plan view. At roof level plan, there should be a grey out wall below the roof level. This is because there is no construction above this level, but we can't see the grey out wall below level planned. So to bring this view back, we need to change some setting. In the Properties palette, go to Underlay category, change range base level to level 0 and range top level to roof. In the underlay orientation, make sure it is look down from the drop down. Click apply to make the changes. Now the external wall appears in a grey line. Left click to select any grey line if you want. To add a roof from this level, select Architecture tab. In the Build panel, select Roof by Footprint. From Modify, create Roof Footprint panel. In Draw panel, pick Wall in the option bar for overhang. Set the length to 350 mm. You then hover the cursor along the wall. You will see a preview how the overhang will be placed. You can have both inside and outside the building to have an overhang. Place the overhang from outside of the wall for the four sides and click on the preview to select. The corner will tidy themselves up and give you a connection. In the Property palette, change the slope in Dimension section to 30 degrees. This will automatically change all the four edges of the hip roof. To see the completed roof, click on the tick sign in the Mode panel. Now go to the 3D view. To see the hip roof, we can change the slope from the 3D model by dragging the height in the model. You can change the roof type from the Property palettes. To change the hip roof to other roof types, in the 3D model, select the roof by grabbing one of the edges, then go to the Modify Roof tab, Mode panel, Edit Footprint command, and it takes the model back to the roof level. Select the shorter size of the wall, untick the Define Slope. The angle symbol disappears. That means it turns it from a hip to a gable end. Repeat this step for opposite ends, so both ends of the model become gable walls. Go to Rule tab, Edit Footprint tab, Mode panel, select tick symbol. To extend the gable wall into the space, select the gable wall, Modify Wall tabs. In the Modify Wall panel, select on Attach Top Base command. You can read the command line at the bottom below View Control option bar. If you are not sure how to do this, click on the roof you want to attach. Repeat same steps on the other side of the gable wall to attach the wall to the roof.